Software visualization is a very broad topic that covers a lot of the SDLC, but given today's time limits, we'll be talking about a few specific aspects of it that would help us. So let's just look primarily only at code-based visualization. So why software visualization? Studies show that developers, we spend more than 25% of our time just navigating through a code base, whether it is good code that's highly modular, structured, or as code bases eventually tend to become spaghetti code. So why do we do this? We navigate through this code to answer a lot of our questions. These are just a few of this, like from understanding what a code base does to identifying specific data flows, function flows, or even like what are a module's dependencies, and a lot more. And when we do all this, we keep a lot of this information in our heads, and these are called mental models. But but surprisingly, not all of us have the same mental models, because software is very hard to visualize to a real world metaphor. Now, although throughout the SDLC, there are many places where we have diagrams and visualizations. Like the most common thing that many people would be familiar with are UML diagrams during the design phase, where we have diagrams such as the class diagrams, sequence diagrams, and use case diagrams that enable you to explain the structure of a software to people, right? And then when you move on to testing, deployment, and monitoring, you again have a lot of visualizations that enable you to show how software is working, its behavior. But when you think about the implementation aspect, the aspect where we spend a lot of our time in, we don't really have a lot of visualizations. Now, software visualization is not a new concept. The goal of software visualization is to identify mental models and metaphors that can help translate software to a physical metaphor that people can easily understand. Why are we doing this? Because that is how we can communicate with each other about the software that we develop. So this domain has been there for more than 2 decades, and that book particularly was written 2 decades ago, and that indexes every single effort that was done by various researchers over time to describe how a software evolves. This becomes very necessary when you're thinking about scale of a software. Maybe like when you build a project that's initially small, you actually put in a lot of effort to structure it and then design it. But then as your code bases grow, which naturally happens in enterprise settings as well as large open source projects, millions of lines of code, how do you communicate that? That is where software visualization can help. Now, software visualization is broadly categorized into 3 areas. One is the software structure, the other is the software behavior, and then the final thing is software evolution. Software structure represents the static structure of the software, and this is where most of the design diagrams that we currently use are also fall under. Software behavior is kind of hard. It depends on the technology stack that you use. There are certain technology stacks or domains that can directly translate to good visualizations for the behavior. For example, robotics. You have a lot of things like behavior trees and simulations that can show you how your software works. But what about an enterprise resource management system or a warehouse management system or an order booking system? It is hard to visualize the behavior of these things. The final thing is software evolution. Here, this is an interesting topic because as your code bases are not static, it's not done in a day. This evolve over time, and as things evolve, a lot of people work on the software, and a lot of things happen, and multiple parallel changes keep happening in your software. There, you can analyze all of this data. We'll get to some cool visualizations there, and you can analyze a lot about dependency tracking, change impact analysis, and you can make decisions about whether to refactor my code, optimize my code, and performance evaluation, etc. So with that overview, that is software visualization about structure, behavior, and evolution, let's get into the challenges and the benefits of software visualization. So many of you, as I keep talking about UML diagrams, many of you, depending on the language stack that you use, you may already be familiar with a way to auto-generate your code diagrams from your code, such as if you use Java and Eclipse or IntelliJ IDEA or if you use tools like star UML, which is what's represented here, you can actually draw out these UML diagrams, and then that can get generated into stub code from which you can start working. And some of these extensions also generate these diagrams directly from your code base automatically, but they have their limitations. Now, this is a very simple system that has like 5, 6 classes. Now, think of a 5 million line code base. When you auto generate a UML diagram, that's just going to be a lot of classes, and you can't actually. You'll have to spend a lot of time filtering through it, and then getting it to a place where you can make some sense out of your software system. So then, researchers at that point in time will represent software, especially very large code bases. Uh, that is a cityscape. So for this, people, what since software does not directly translate to a physical metaphor, people have been trying to identify a lot of metaphors. One such metaphor is a cityscape. Now, this again is a very old visualization, but the idea behind this is every single building essentially stands for a class or a function, and then a collection of buildings could be a class, and then an island could be a module, and then your lines that connect each of these islands are your dependencies and imports. Now, these kinds of visualizations have their benefit. You can actually see how big your code base is, but they have their challenges as well, like I'll talk about. Imagine again a 5 million line code base that you generate the cityscape for. How do I read this? If I don't have any idea whatsoever of what I'm looking at, I'm just looking at a diagram, a very complex diagram. Does not solve the use case. But despite that, these cityscapes have stuck around for a very long time. Now, this is an open source project that you can check out right now. It's explorevis.dev. This works on Java code bases. But as you can see, here again, you see a cityscape. This is a pet clinic sample project that's on Java. So this is how it's visualized. As you can see, each of these individual modules, and then the classes and how they are connected to each other, how they are imported, all of this are now thrown into mixed reality, but the idea is still being the same. And this would also have the same problems when you go to a larger scale. There have been other ideas on how we can better represent our code bases. Now, this is a project, this has shut down right now, but the idea behind this project was, can we have a better way to enable people to understand our code? Can we logically group our code in ways that can better translate to our mental models? So here again, the code is analyzed, and then it's categorized into different like execution points, like the entry point, then where initialization happens, then where the functions are defined. You can actually logically navigate this code base. This, of course, is better, but then again, the same problems of your language. Many of these tools are language specific. They can only work on Java, they can only work on C++, or they can only work on C#. And then there's a lot of work that goes into explaining this code to you. Most of these systems work with static code analysis and not actually use any sort of logical understanding of what is happening. So because of which, you are limited by visualizing a structure. Let's see how there are other tools in the other ecosystem. Like these are some Python examples like that will enable you to extract your dependency graphs. And on the top there you see Wistracer. Wistracer is an extension that you can install that will actually show you how your function is or your class is executing, and then you can see how long it takes, and you can navigate your code base that way. This helps you in optimizing your code. And at the below, this is actually a research effort that took place a while back, wherein when we're looking at code bases for optimizations and refactoring, would it be good if researchers or like the developers actually got signposts in their code that can actually tell them exactly how much time a particular line of code is taking? Now, again, this did not actually materialize into a usable open source product, but researchers are always working on these kinds of things. When we come to evolution, as I mentioned earlier, we have all this metadata that is around the code. It's actually very interesting that when you think about it, it's not just the code, but your version control history and your project management data, your metrics. can we actually visualize that? And when we visualize that, can we infer any meaning? Can we understand things about how our code base works and how our team works? Here is another open source project. It's called Gorse. This actually which takes your metadata around your code and then starts visualizing it as a Bloom diagram, and it shows you how over time uh, how many people were working on what projects or what parts of the module, and then it shows you over time how your project is evolving and then who is working on what. Now this is exported as a cool little movie to use, but can you actually get more data driven insights from these videos? As you can see, as the timestamp on the top keeps moving out, the project kind of stabilized after a while, and then the users are only working on certain modules and like improving it, keeping it up to date. You can actually get this information right out of your code base metadata. Now this is another project called CodeScene. This is not completely free. There are certain aspects that are free, but it's also paid. The idea here is those insights that you just saw in the video, they can actually be visualized as usable metrics. So from code hotspots to architecture to team dynamics to system performance, all of this information extracted directly from your version control metadata. So what are code hotspots? For people who are not familiar with code, hotspots are the regions of the code where a lot of activity is happening. This is important when you want to actually identify the areas where you need to do a lot of refactoring or optimization. If basically the rule of thumb is that if a lot of people are working on one single file, then that file needs to be split across and to make modular. So to make design decisions, such visualizations become essential. This talk, there's actually a talk specifically about this and how what all insights can be derived from your metadata. It's called Your Code as a Crime Scene. It's also a book. It's an interesting way to look at code. But despite all of this, if you look at our stacks today, we don't actually use a lot of visualizations. We just open up our IDEs and we start writing code. Why is that? Like I mentioned earlier, a lot of the time, it's about not having an intuitive representation that you can actually immediately transfer your ideas to. And there's a learning curve with any of these visualizations. You have to spend a lot of time understanding how these visualizations help us. And some other time, these visualizations are not automatic. Like, let's say you're using OpenTelemetry, and then you'll have to instrument every part of your code if you want to visualize your optimization and performance. Then maybe these things are not easily integratable into your existing workflows. They are, as I mentioned earlier, they are very, very stack focused. Like some things work only for Java, other things work only for C#, and other things work only for C++. And sometimes, but more importantly, it's all this information overload. There's no way for any particular person when you're looking at very large code bases, they're overwhelmed by all the information that they get, and they lack the context that's required, because you don't need to see all this information every single time. There are, maybe one day you're trying to understand your code base, but other days you're just trying to find out how a particular function flow works. But this, again, is an open problem. It's not solved. But can we actually make a more focused, intuitive, and stack agnostic visualizations that can enable us to understand our code bases better? Right now, with the evolution of generative AI and better code understanding, these things could become possible. There are three key things that need to be solved for us to generate usable visualizations. From the first aspect is code understanding. How do you understand large volumes of code? And the second thing is, what are these metaphors and mental models? Or if people have different mental models to understand their code bases, can we have a visualization engine that can actually represent those unique visualizations for each people? And then that's basically context-based personalized representations. And then you finally need the technology to enable that. AI agents today, like GitHub Copilot or any other code understanding tools, do work for small number of lines of code. Like maybe you can take a 2,000 line code and then ask GitHub Copilot to generate a sequence diagram for me, and it will actually generate a sequence diagram for you. They to diagram right now we have a lot of these languages such as Mermaid.js and Draw.io. These are all descriptive languages like LaTeX, if you're familiar with that, wherein you can describe a diagram, because of which it translates very well to the large language model use case, because then it's essentially just doing text to text. It is trying to understand one form of text and then describing it in another form of structured text. So you can actually try this out today. You can take any small code base and then ask Copilot to draw a diagram for you. But then as these code bases scale, even Copilot or any other large language model for that matter cannot out of the box describe that diagram in great detail. They become very abstract. So if I'm trying to explain a simple order management flow, if it's a very small system, I'll actually get descriptions of the exact classes. But if it's a very big application, then I'll actually that basically say order inputs, order processing, order validation. That does not actually give you details about the exact implementation, but only a high level overview of what the code base is doing. And they may or may not be correct, because hallucinations and correctness and repeatability of large language models are a problem. But you can work around this too. There are certain approaches, but since the technology itself is very new, all of these research activities are currently in progress. There's a lot that is happening in software visualization research today. So from understanding what our mental models are, how do each of us think about the code base, and how do all of us keep all of this information about a particular code base in our heads while we can't really describe it? Because it is easy for a person who has been working on a particular code base to explain everything about it to you. And while this person is translating all this thought from his head to English or whatever language, there's a lot that's happening from converting your mental model to understandable standardized models. Then there's work on trying to understand exactly the cognitive load, the learnability, the emotions that surround people when they are navigating these code bases, and how can visualizations deal with the increasing trend of this complexity? Because as I said, these visualizations currently don't scale to very large code bases. And this last work, can LLM-based agent workflows be used to understand code and visualize code better? That is actually an open problem that even our team is working on. We are Wipro Lab 45 Research. We work on a lot of these upcoming research areas, from software visualization to robotics and other domains that involve a lot of generative AI. This is our work, and we are making progress, but software visualization as a domain still actually can benefit from a lot of your inputs today. And if any of you find any of this interesting, you can always, yes. Okay, cool. Yeah, so if you all find this interesting, then there's a lot of ways you can contribute, like from going to finding out all these open source projects that I mentioned earlier, and you can start contributing today to that, or you can actually get in touch with the researchers that are working on this, like us, or there's a small website that at the end that says softwarewiz.wordpress.com. So there, it's a community-driven project wherein researchers are indexing every single effort that is happening in this space as much as possible. But very soon we could actually end up in a place where we are not just coding with text in our IDEs. Maybe we are programming visually, and we can describe any kind of a project, a system, using visual data, and then navigate from visualizations to code directly, because all that could become possible soon. So with that, I'd like to conclude my talk. Thank you. Thank you then.